Happy morning students. I welcome you all to the physics online class. Last class we learned lesson number 5, acoustics. Have you remember what are the things we learned in the last class? Did you all learn the portion? Yes? Okay. Tell me what are the things we learned in the last class? First we learned about the velocity of sound, isn't it? There is two types of velocity, particle velocity and wave velocity. And we learned what are the factors affecting the velocity of sound. Okay. And we learned about the reflection of sound. The reflection of sound, what do you mean by reflection? And it obey the laws of reflection. We studied, isn't it? What is laws of reflection? And next one, we learned about the reflection at the boundary of a denser medium. And also we learned the reflection at the boundary of a rarer medium. Okay. And reflection of sound in plane and curved surfaces. If it is a plane, curved surface, if it is an elliptical surface, means how the sound wave will be reflected. And today we are going to learn about echo. And what is the condition necessary for hearing an echo, and application of an echo, and how will you measure the velocity of sound by the echo method. And also we are going to learn the application of reflection of sound. Okay. Are you all ready to listen the class? Yes. Okay. Good. What do you mean by echo? You all know that, isn't it? You all heard about the echo sound. An echo is the sound reproduced due to the reflection of the original sound from various rigid surfaces like walls, ceiling, surface of mountain, etc. If you stand near the mountain and if you are speaking, what you can hear, we can hear our echo sound, isn't it? Yeah. So, echo is the sound reproduced due to the reflection of original sound. Okay. What sound we are speaking, that sound it will be reflected back from the rigid surfaces. Okay. If you are standing in front of the mountain and if you are speaking something, your sound it will be reflected from the surface of mountain and you are getting that sound back. Okay. That is called as the echo. Okay. So what do you mean by echo? It is the sound reproduced due to the reflection of original sound from various rigid surfaces such as walls, ceiling, surface of mountain, etc. In this picture you can see whatever the sound we are speaking, the sound is reflected from the wall. Okay, and the sound it will be reflects back and we are getting that reflected sound again. That is called an echo. If you stand nearer to the mountain and if you are speaking, your sound it will be reflected back from the surface of the mountain. Okay, so echo is a reflection of sound. Next we are going to learn the condition necessary for hearing an echo. Okay, so if you are standing near in our house, any room, if you are talking something, we cannot hear the echo sound. Do you know why? So, certain condition is necessary for hearing an echo. That only we are going to learn one by one. The first one is the persistence of hearing for human ears is 0.1 second. Okay. So, within that time interval, the reflected sound and the original sound, the time interval between this hearing and hearing the sound interval between the reflected sound and the original sound should be 0.1 second. Then only we can hear the echo sound clearly. Okay. So, in this time interval, you can hear the two sound waves clearly. Okay. And if the time interval between the two sound is at least 0.1 second. Okay. That is the first condition. The time interval between the two sound is at least 0.1 second. Okay. So, the minimum time gap between the original and the echo sound will be 0.1 second. This is the first condition. Okay. The minimum time gap between the original sound and the echo sound must be 0.1 second. Okay. In this time interval, if it is there only, we can hear the echo sound. The second one is it can be satisfied only when the distance between the source of sound and the reflecting surface would satisfy the following equation. Okay, distance. Second condition is the distance will be on particular distance it is there. Okay, how to calculate the distance is by using this formula, that is velocity is equal to, you all know the distance travelled by time taken. Okay, so distance travelled by time taken is called velocity. Okay, so here how we can calculate the distance travelled. See the distance traveled, how we can calculate means, see here, this is the source of sound. Okay, source, and here this is the rigid surface, that is the reflecting surface is there. Okay, so here the sound is traveling from the source to reach the reflected area, that is D. Again it will be reflected back to the near to the source, that is D. So D plus D, okay, that is 2D. Okay, the total distance traveled by the sound wave is 2D. Okay, so 2D and divided by T be the time. Okay, so 2D divided by time. So from this we can calculate how much distance is required for the echo. Okay, so how will you calculate? D is equal to, okay, D is equal to, here what is there? V, isn't it? Velocity. So take this T here. So Vt divided by 2. Okay. Next step, distance is equal to velocity into time divided by 2. Already we know what is the time gap between the original sound and the reflector sound. What is that time gap? Should be 0.1 second. Okay. So 0.1 second, here we can substitute D is equal to V into 0.1 divided by 2. Okay. So V into 0.1 divided by 2. Okay, so here this is the decimal number. So what we have to do, both sides multiply and divided by 10. Okay, so 0.1 into 10 is 1. Okay, so V into 1, V. So V divided by 2 into 10, what is that? 20. Okay, so V by 20, that is the minimum distance required to hear the echo is 1 by 20th part of the magnitude of velocity of sound. Okay, 1 by 20th part of the 1 by 20th part of the magnitude of the velocity of sound. Okay, so if it is there only, we can, the distance is this much only, we can hear the echo sound. Now how to calculate the distance? Consider the velocity of the sound in air is 344 meter per second. Okay, the velocity of the sound is 344 meter second per minus 1. Okay, so the minimum distance required to hear the echo is, how to calculate from this, the velocity 344 meter per second divided by what? 20. Okay, so according to that, the last formula we learned, what's that? We learned V by 20, isn't it? So velocity of the sound is 344 divided by 20. So if you are calculating this value, we can get what? 17.2 meter. Okay, so the minimum distance to hear the echo sound is how much? 17.2 meter. Okay, that is 17.2 meter. So in between the distance from the source and the reflecting surface is 17.2 meter means we can hear the echo sound. Next we are going to learn the application of an echo. What are the uses of this echo? Okay, the first application is some animals communicate with each other over long distance and also locate the objects by sending the sound signals and receiving the echo as reflected from the target. Okay, some of the animals communicate with each other over long distances and locate objects by sending the sound signals and receiving the echo as reflected from the target. Okay, see examples. Two whales will communicate with each other under the water. How it will be communicate with each other by sending and receiving the sound signals. Okay, so this is one of the example. Okay, then you all know that the bat will produce the ultrasonic sound, isn't it? To identify its prey, it will be sending the high frequency of the sound. Okay, so when it is flying that particular area, is there any obstacle is there, easily it can able to find out. Okay, so these are the one of the application of this echo. And the second one is this echo is, it is used in the obstetric ultrasonography. Okay, it is used in the medical field. Okay, what is the use of this ultrasonography? Which is used to create the real-time visual images of the developing embryo. Okay, developing embryo, that is called as the fetus, isn't it? In the mother's uterus. Okay, how the development of baby, the particular month they will check. Okay, they will take the ultrasonography. Okay, it is a safe tool to measure the or to identify the condition of a baby in the mother uterus. Okay, so here also the same principle of echo it is used. This ultrasonography is a safe testing tool. So it does not have any harmful radiations. Okay, so that only they are using this particular ultrasonography to check the condition for the developing embryo. Okay, and then last one is the echo. It is used to determine the velocity of sound waves in any medium. Okay, the echo is used to determine we can calculate the velocity of the sound waves in any of this medium. We can calculate by using this echo method. Okay, so these are the applications of an echo. Okay, here you can see the images of the developing embryo. Okay, so in the medical field, how the ultrasonography it is used to check the developing conditions of the developing embryo. Okay, next we are going to learn how to measure the velocity of sound by echo method. Okay, how we can calculate the velocity of sound using echo method. What are the apparatus we require? A source of sound pulses and the measuring tab and sound receiver and a stopwatch. Okay, sound pulses we need, measuring tab, sound receiver, okay, and a stopwatch. Okay, first step what we have to do, you can measure the distance between the source of sound pulse and the reflecting surface using the measuring tab. Okay, so here suppose here is the source of sound is there. Okay, the sound pulses are coming from the source of sound to the reflecting surface. Okay, so that distance we can measure by using the measuring tab. We can measure the distance. That is the first step. Next step what we have to do, the receiver also placed is nearer to the source of sound. Okay, you have to place the receiver nearer to the source of sound and we can collect the receiving that reflected signals. It will be collected by the receiver. Okay, a sound pulse is emitted by the source. Okay, and it will be now we have to take a stopwatch. It is used to note the time interval between the instant at which the the sound pulse is sent and the instant at which the echo is received by the receiver. Okay, I have to note the time interval, that is t. Okay, so first what you have to do, source of sound is there. No, from the source of sound to how much time it has taken to yes, it will be coming to the reflecting surface. Okay, so time interval you have to measure. Okay, how long time it has taken to sending and receiving. Okay, so here you have to place the receiver nearer to that. So the receiving signals also how much time it has taken. Okay, so you have to be on the stopwatch and you have to note the time interval between the instant at which the sound pulse is sent. Okay, how long time it will be taken to send and at the instant at which the echo is received by the receiver. Okay, that time interval also you have to note it down. Okay, that is the third point. Now repeat the experiment for 3 or 4 times. You have to repeat the experiment. Then we have to calculate the average time. Okay, average time interval taken by the given number. Okay, so that from that average we have to calculate the time t. Okay, so first step what we did, first you have to measure the distance. Second one, the receiver is also placed nearer to the adjacent side of the source. Then sound pulse is emitted by the source. Isn't it? That next what we have to do, stopwatch is used to note the time interval between sending and receiving the signal. Okay, we have to repeat the experiment for 3 or 4 times. Then we have to calculate the average time. Okay. Okay, next step we can calculate the speed of sound. The sound pulse emitted by the source travels a total distance. Total distance how we can measure, already we studied, isn't it? Total distance, sending and receiving the distance, it is equal to 2d. Okay, for sending the distance d and from the reflecting surface to receive. Okay, that also nearer to the source only, no, that distance is d. So d plus d, 2d. While traveling from the source to the wall and then back to the receiver. Okay, so total distance is equal to 2d. Next, the time taken for this is observed from the stopwatch. Okay, already we measure the time, that is t. Now, speed of sound, what is the formula? You all know that the formula, distance travelled by time taken. Okay, speed of sound is given by distance travelled by time taken. So, the distance travelled what we calculated? Yes, 2d. Okay, 2d divided by t. Okay, so by using this formula we can calculate the speed of sound or the velocity of the sound. So this is which method? Yes, echo method. Okay, by using the echo method we can calculate the velocity of this sound. Okay, Next we are going to learn application of reflection of sound. Okay, application. What are the application of reflection of sound? The first application is what device is soundboard. You all know that what is soundboard, is it? These are basically what shape curved surfaces or concave surfaces there. Okay, so you all know that the concave surface, if the sound is incident on the concave surface, after that what it will happen? It will be what? Yes, it will be converge in one particular point. Okay, all the sound from the concave surface, it will be, yes, converged in one particular point. Okay, it will be converged in one particular point. Okay, so usually the concave surfaces, the intensity of the sound will be maximum. Okay, so it is which are used in the auditorium and halls to improve the quality of the sound. Okay, it is used in auditorium, mostly the big auditorium and halls, to improve the quality of the sound. They are using this concave surfaces of the soundboard. Okay, and it is placed such that the speaker is at the focus of the concave surface. Okay, nearer to the concave surface they will place the speaker. Okay, the sound of the speaker is reflected towards the audience, so the improving quality of the sound is heard by the audience. Okay, sound of the speaker is reflected towards the audience, so the improving the quality of the sound will be heard by the audience. Okay, so the audience can be able to clearly they will hear the sound. Okay, they are using this soundboard. Okay, these are what surface? Concave surfaces. Okay, to improve the quality of the sound they are using this type of soundboard. Okay, it is placed such that the speaker is at the focus of the concave surface. Concave surface, nearer to that they will keep the speaker. Okay, so to improve the quality of the sound they are using this speaker. Okay, the sound of the speaker is reflected towards the audience, so the improving the quality of this sound, it will be heard by the audience. Do you know what is this? Yes, this is the image of the soundboard. Okay, so here it is the soundboard, and this it will be what? Connected nearer to the speaker. Okay, the curved surface nearer to the speaker. So the sound of the speaker is reflected towards the audience, so the improving quality of the sound is heard by the audience. The next application is ear trumpet. Okay, so this it is one type of hearing aid. Okay, so the people those who are difficult in hearing, they are using this ear trumpet. Okay, the ear trumpet, you all know that how it will be means, it will be one end it will be narrow, another end is it is wider. Here you can see the images of the ear trumpet. It is used by 18th century. Okay, so olden days the people used this type of ear trumpet. Okay, and nowadays what type of ear trumpet we are using? See, nowadays we are using this type of hearing aid. Okay, so it is a type of hearing aid. Those who are suffering, the people those who are suffering difficult in hearing, they are using this type of hearing aid. Okay, here the one end it will be wide and other end is narrow. The sound from the source falls into the wide end and it will be reflected by its walls into the narrow part of this device. So it helps in concentrating the sound, and the sound enters into the eardrum with more intensity. So the person to hear the sound better. So we learned about the ear trumpet. It is a hearing aid which is useful by people who have difficulty in hearing. In this device, one end is wide and other end is narrow. So the sound from the source falls into the wide end and are reflected by its walls into the narrow part. Okay, from the source to it will be many times it will be reflected into the narrow wall. Okay, so the intensity of the sound will be increases. It helps in concentrating the sound, and the sound enters the eardrum with more intensity. So the person to hear the sound is better. Okay, so this is the application of the echo. Okay, reflection of sound. The next one is megaphone. Megaphone is a horn-shaped device. You all know, isn't it? So it is used to address a small gathering of people. Okay. You may seen this one in the pictures and all, isn't it? The megaphone. Why they are using this megaphone? To the group of people. Some people, if they announce anything, they will use this megaphone, isn't it? one end is narrow and the other end is wide. Here also the one end is narrow, another end is wide. When a person speaks at the narrow end, the sound of his speech is concentrated by the multiple reflection from the walls of the tube. Okay, so one end is narrow, another end is wider. Okay, so what will happen? Whatever the sound signal is coming from the narrow end, okay, it will be getting multiple reflection inside the wall. Okay, after that it will be spread out in this surfaces. So his voice can be heard loudly over a long distances. Okay, so this is the use of this megaphone. Now we are going to mark some questions. Okay, take page number 64. One entity is what is an echo? Echo is the sound reproduced due to the reflection of the original sound from the various digit surfaces such as walls, ceiling, surface of mountain,
reflection. Okay,
and
from the walls it will be getting multiple
what are the
reflection,
conditions necessary
and
for
so
hearing
the
an echo?
voice of this
First
person
point
can
to
be heard
till
loudly
17.2
over
meter.
a long
Next
distance.
question, what are the application of an echo? These 3 points. Okay, and next question, how will you measure the velocity of sound by echo method? Apparatus required to till this 4 point. Then calculation of speed of sound. Speed of sound is equal to distance traveled by time taken 2d by t. Next question, what are the application of reflection of sound? First application, what? Soundboard. Then ear trumpet, megaphone. Okay, so up to here just you have to mark and learn. Okay, so today your homework portion page number 64 and 65. Okay, so today marked question you should learn and write in your note. Okay, thank you students.